This is video number 1 for section 5.5, easy case where A and B are given. So in this section we return to the application problems that we did at the end of chapter 4. Only now we can answer a few more questions about those problems because we've learned about logs. And I'll make sure to point out where the new material is. Okay, in this video, we'll consider the easy case, the one where you pretty much know the A and the B right from the beginning. So you can see our sample problem here. This is an investment problem. Somebody puts some money in an account. It grows by 6.75% each year. And Jana puts $1,200 there in 2015. We're supposed to figure out how long is it going to take before she's doubled her money. If we're going to use a model to help us figure this out, we need to start with a let statement. And I've started one out here. We'll use V to represent, of course, the value of her investment. And maybe it should say in dollars. And T will stand for years since, let's see, we should use 2015 because that's the first year they mentioned. What kind of function are we going to use here? We've only learned about two, linear and exponential. I know you're not shocked that the answer here is exponential, but the reason is because of this. When you see something changing by a constant percentage, then that is the tip-off, or that is one tip-off, that you're dealing with an exponential function. Now we want to write an equation for this model. It is an easy one because we don't really have to do a lot of work to get the A or the B. The A is certainly the easiest. That's the y-intercept. Since we picked 2015 as our starting year, the A would just be the value in 2015, which they told me was $1,200. In other words, 0, 1,200 is a point on my model. 0 years since 2015. In other words, in 2015, the account was worth $1,200. So A is 1,200. As far as the B, they didn't hand it to me directly, but I can get it pretty easily using that little formula B minus 1 equals R. Remember, there was that connection between the base multiplier and the constant percent. The R is the constant percent. They gave me the constant percent. I just need to write that as a decimal and then solve for B. So let's see, that would be 0.0675. And then if I add 1 to both sides, I will have 1.0675. That would be the value of the B. Now that I have the A and the B, I can write down the model, no problem. Let's use the right letters. My y variable is V in this case. It's A times B to the x. So 1,200 times 1.0675 to the, let's see, who's my x in this problem? It is t, to the t. All of that is review. We've done all of this stuff earlier in this unit. Now question D gets at the new part. It says, let's answer the original question using algebra. The original question was, when is the account going to be worth double her original value? She started with $1,200. Double that would be $2,400. So we're trying to figure out, when is this going to be up to $2,400? Well, I can either plug in a value or I can plug in a time. Clearly here I'm being asked to plug in a value of 2,400. So let's do that. And you might remember we posed some questions like this at the end of chapter 4, but back then we could never figure out how to get the t out of the exponent position. So the only way we were able to solve something like this back then was to use the graphing calculator in some way. Now that we've learned about logs, that's no longer necessary. We can just do this using straight up algebra. First step would be get rid of the junk in front of the base and the power here. That would be the 1,200. It's being timesed. so I can get rid of it by simply dividing both sides by 1200. Let's write down what we have now. The left side simplified to 2, since 1200 goes into 2400 evenly. If it hadn't gone in evenly, I would have just left the fraction sitting there. And the right side, now I'm down to just the base and the power. This equation is now in exponential form. And once you're in exponential form, that's when you can introduce logs. And that's my next step. Log each side. We're talking about the base 10 log, right? The one we have on the calculator. So I log the left and I log the right. Why would I do such a thing? Only because of that great rule of logs, the power rule of logs, that says if you have the log of a base raised to a power, you can take that power and move it down to the front as a multiplier. Let's go ahead and do that. And so now the t is down there on the main line. It's t times this number, whatever it is, equals this other number. I can get t by itself very easily. Just divide both sides by this logarithm. And t is now by itself. These logarithms cancel out. I have t equals this fraction consisting of two logarithms. Remember, log 2 is just some exponent. I don't know what it is yet. Log 1.0675 is some other exponent. I just need to divide those two exponents by each other, and I have my t, which means there's nothing left to do except reach for the calculator and see what we get. I got about 10.6 off of the calculator. We usually round to the nearest whole year, so that would be about 11 years. Let's see, I'm supposed to give my answer, though, as an actual calendar year. In what year? So I got to go back up to my let statement. T stood for years since 2015. If I add 11 to that, I'm going to end up with the year 2026. So we're saying in 2026, her account is now going to be double of the original value. If I ask you on a quiz or a test to use algebra to answer a problem like this, these are the steps that I need to see in order to give you the credit. So make sure you're practicing the step by step as you're going through the